Sunday. Welcome to Steve's Place. Tonight, we're going to have a great guest. I haven't seen since about 1992, Scott McKie, and he'll be introducing some uh, exciting technology. It's not exactly new technology, but it's new to us. Okay. And anyway, he's going to go and explain how he came about that and that. In the meantime, I'd like to remind everyone we have a conference coming up. And if you go to testatech.info, just click on the QR code there, and that will take you to it. And also on testatech.info, uh, you can see this little banner here, the Testatech banner, and you click on that, and it will bring up the how-to page. On how-to, you can get the last year's conference. It's $99. You get for life, and you get 30 some odd hours of video there. We get all the conference presentations, plus you get all the outtakes, from Jason and Karen as they interviewed various inventors and researchers there between the actual presentations. We also have a green bar there where you can actually donate some money to the cause here if you'd like to. Every penny counts and really helps us out. We also have T-shirts for sale there too. There's the design. You order them and you can get those right away. Okay. And I also like to remind everyone we do have a YouTube channel for those who don't know. And on the YouTube channel, we have over 1,500 videos. We have two categories. One would be subscriptions. Everyone should be a subscriber. Even members should be a subscriber and get notified of all the videos that we put up there, which kind of slowed down the last couple weeks because computer problems. I'm hoping to get that fixed as soon as possible. They're supposed to be getting me another computer here. We'll see. And then we'll start getting some more up there. We have all the extraordinary technology conferences, all the exotic research, except for last year's, and then the exotic research conferences, and we have most of the global science congresses. In the past, we were hit hard by YouTube because of some of the topics that were covered on global science, but I think that's going to go away now, since how we have a change of administration for what it's worth, But we'll see what happens there. And to go, all you got to do is just go to the testatech.info and the yellow box in the right-hand corner. And in that yellow box, you can see that we have the channel, overall channel. You click on that, take you right to the channel. We also have a conference directory. If you click on the conference directory, it'll bring up a list of all the conferences we have up there. You click on the red YouTube channel, it'll bring up all the speakers for just that conference. And we also are building up a speaker directory where we have all the videos listed by speaker. So if you click on a speaker, it'll bring all the videos that he did that we have online there. And remember, all these videos that you see online are available as DVDs if you'd like to get that little bit of insurance where you don't have to worry about the YouTube going out of business or whatever. And let's see. And oh yeah, don't forget to hit that thumbs up there and help us out. And here's another. So easy as 1, 2, 3 pi. Anyway, without further ado, let me bring Scott up.
Hi, Steve. How are you?
There we go. It's good seeing you again.
It's been a long time.
A very long time. And you invented the PODMOD back in 84. And I believe you first ran into this in 82 when you were working on some power lines.
Well, what happened was I'm a early 1960s grad of U.S. Navy Class A electronics school and Class A radar school. And in ET school, Tesla was part of the curriculum, specifically about resonance is what really caught my eye. And I started messing around in the lab a couple of days and started getting results that were not in the books, which did not please my instructors at all. And I was told I either shut it down or I'm going to go to the, out to the fleet as a bosun's mate. And I did not want that. So I had to wait until I got out to start really researching it in 1975, because I had definitely gotten the Tesla itch. There was something there that I wanted to find. And when I was researching his patents at the University of Washington, I found the actual patents that just blew me away, because what it was the actual foundation for what they had been teaching me in ET school. Because when you go to school, you listen to what the instructor is going to tell you because you want to get through the course. And I have yet to see a course on anything that goes back and teaches you the foundation for what they're teaching you. So you start at point 9 and go up from there. And I went back to point 1. And it turns out that Tesla, the timeline is this. 1882, he discovered multi-phase AC power that the world now uses today, and he patented that in 1888. But in 1894, he patented what he called his electric generator, and in that electric generator was the tank circuit, which is a capacitor and an inductor connected in parallel. No big deal. In there also was electric resonance, unclaimed. He then took that, combined the two as the radio receiver in his 1900 patent for a system for transmission for electric energy. That's the radio. And that's where I realized that I had found what the origin was of what I was learning, but I didn't know how it worked, because I had been taught in school 2 terms that really didn't mean anything, and they didn't do anything in explaining it. Maximum impedance to current flow and minimum impedance to current flow. And it took me a long time to realize that those 2 terms we're talking about were the developed power and the input power to a tank circuit. And we've had AM and FM radio since 1900. I mean, that's over 124 years now that worked. But what made them special? It turns out that every resonating tank circuit, when it's tuned to a specific frequency that you want to listen to on a radio, or if you want to tune it to 60 cycle or anything like that, it develops its absolute maximum power inside of it, but it also electronically reduces the input power connected to it to the absolute minimum. Now, it never goes over its maximum. And this is the important thing. We've been taught since the 1850s by physics that no power supply can produce more output power than input power, inferring that, quote unquote, overunity just isn't possible. But there's nothing in physics that says that you can't turn down the input, which is what a tank circuit does automatically. That's that maximum impedance to current flow. That's the current coming into the tank. The minimum impedance to current flow is what's developed in the tank. That is an overunity ratio. And because the thing doesn't go over its maximum, it never increases or exceeds maximum. It doesn't break, it doesn't bend, it doesn't get even close to breaking any laws of anything. Thermodynamics hasn't got anything to do with it because that's steam. Conservation of energy hasn't got anything to do with it because, to be perfectly honest, that's a theory at its base. Perpetual motion doesn't apply. Sustained action doesn't apply as long as you have a timed input into the tank circuit. Now, at a radio, That's an AC signal. But in semiconductor electronics, which the PODMOD is, it's a timed 12-volt square wave, real skinny duty cycle per cycle. So consequently, what you've got, it's the same thing as when you got a child on a swing and you get them going to where they want to go. You're just a little bit of input and they got the full swing going. Or when you hit a bell, and if you hit it every time that it comes back, it will continue to ring at the same amplitude, minus a little bit per swing. That minus a little bit per swing is what you have to put back into it to keep it going at maximum. When I started this thing in 75, I had that. By 1982, I'd been able to cobble together a basic system that produced 103%. And in the process of doing that, I had to convince a friend of mine who was a retired ET chief from the Navy that what he was teaching his class at the local college where he was teaching was not what was going on inside a tank circuit. And it's because of being able to develop the vocabulary for him that I was able to take a look at what all of the information had been written, find out what was pertinent and what wasn't. And we've had the ability to produce all of the clean, electronically develop all of the clean energy the world has ever needed. But because of the physics verbiage that no power supply can produce more output than input, we didn't look for it. I'm a Scotsman. I'm ornery as hell. I don't take no for an answer. And so consequently, it's taken up till now. The PODMOD now has gone through many variations. 1984, it was professionally tested by Northwest Test Labs here in Seattle. 293% overunity. And what it was a 60 cycle system. I took wall power out of the wall, put it into a first AC motor, 120 volt, 60 hertz. That directly drove an AC generator, whose output then drove a second AC motor. What I did was I used the armature of the second motor as the inductor, and then calculated what capacitance needed to be added in parallel across of it to make a tank. And it worked. Now, in the tests, the licensed engineer that did the test didn't follow the directions that I gave him as far as connection. If you get the copy of this sometime, you'll see a red notation over, and he didn't connect the second or a capacitor bank to the first motor, because I had designed and built the first motor and second motor as two separate tanks at 60 cycle. And that produced over 400%. Driving the motor, vastly reducing the input by 400%. And you can do this with any AC motor that's got a set load on it. Calculate what the capacitive reactance is needed to counteract, to work with the armature of the motor, which you've got to measure first without being connected. So you got that value. You put the two together, you get a tank, and what it will do at 60 cycle is it will reduce its required input because it's the tank that's driving the motor. And this is where all hell breaks loose, because physics doesn't like that. Doesn't fit their learning, their lexicon, whatever you want to call it. It's just, that's the way it is, and it's been that way ever since. I've never even tried to get into an argument with a physicist. It just doesn't work. The next thing that I was able to do was put together the solid state system that was patented in 1992. And going back to 1992, there were not very many chips and things available. I mean, literally, I have had to wait for the electronics industry to produce the units that are now in the chips and things like that, that are now in the PODMOD. It now produces 480 volts, AC or DC, 480 amps. The picture that you're seeing is a 100 amp unit. On the output for the 480, it will have 4 output units in parallel. It works. The input, 12 volts, 1.25 amps. That's controlled by a chip called an LM7812 fixed voltage regulator. Anybody that knows electronics, been around a little bit, they'll recognize that. The ratio is through the roof, but it's simple electronics and calculations. There's a number of things that I've developed over the years by hit and miss that are in this. All of the electronics that are on the left-hand side are now being put on it's about 7 by 8 inches, single-sided board. We're going to keep the right-hand side the same. The overall size of this, of the PODMOD, is going to be about 2.5 square feet, and that's going to be generous. Weighs about 30 pounds. And when you've got what's called regenerative feedback, which is in the patent, if you can flip that up, Steve. There's a circuit that is now common in semiconductor electronics called a regenerative feedback. And what it does is it takes some of the output and it flips it back to the input of a chip to control it. Now, this goes all the way back to when I was in school in the early 60s, where everything electronics was powered by vacuum power tubes. And when you ran a power tube like the Navy had, which were pretty healthy, you had to have a feedback circuit that was degenerative feedback. They would flip the phase, kick it back to the front to keep it from going into what I called resonant overdrive and self-destructing, which could be kind of spectacular sometimes because I've been there, done that. And you got glass going all over the place. But the secret to this thing has been available since the 60s, or actually earlier than that. I don't know how long it's been since they've had feedback in radio. But you control things this way. And when you've got the swing situation where you only have to add a little bit at each swing or per cycle, what you do then, it's through the regenerative feedback. Now, the existing PODMODs now have got an onboard startup power system that is equal to that 12 volts, 1.5 amp. And it starts from that. It's more than that. When this thing kicks off, runs at a 50 kilohertz signal. So it's quick. What it does is the feedback system, which is from the output, kicks back, shuts down the onboard startup power supply, and continues to run the whole thing while it electronically develops. It's up to output. We've got it now so that it has several different output voltage levels done by using series resonance, which is another thing that Tesla discovered and invented and patented. And that replaces transformers. It also lets you get higher voltage by design without cutting down any amperage, because there's no disconnect like you have in a transformer. We've had this for over a century. What I'm trying to do is to get the information out so that it can be produced. I've got 2 units being developed, one right now in Europe from my project partner in Europe, and one here domestically. Funding is in place for those being privately developed for mass production. We want to make them available not for sale, but for long-term lease. We'll put together a not-for-profit company so that we can keep the price low. We're looking at 10 cents per hour, not per kilowatt hour, but per hour, because we don't have any profits to pay, and we don't have any infrastructure to pay off, because you can put this thing at any site or in any vehicle. And to give you an idea on a car, what that means is that the Tesla Plaid, I think, is the most powerful battery-powered car that they've got, that Tesla's got. It's 100 kilowatts. At 400 volts, this thing cranks out 192 kilowatts continuously. No recharging, indefinite range, indefinite time, on land, on sea, and in the air, including high bypass jet engines, because that's been developed already by a professor, C.G. Sintemir, I think at the University of Ohio, and he's got it patented. And he literally takes the combustion section out of a jet engine, high bypass jet engine, and turns it into an electric motor. And the only thing it needs is a power supply. Well, that's the PODMOD. At home, these things are small enough to where they can go into a fuse box right next to the existing fuse boxes. And we're going to put them in as emergency power sources, which is perfectly legal. And there's no law or regulation that says that you have to use the power that comes in from your connection from the utility. So we're putting the things in the hands of the consumer, hoping that the both private and public utilities will get the signal and work with us. Because this whole thing is not to make money, but is to get control and to stop burning fossil fuel. We don't need to. And so it's simply a matter of, well, it's not a matter of us or them. It's something that has to be done. Because the bottom line of it is, whether you agree with me or not, I personally think that human beings are about the only thing that is not going to make it if it keeps going hot the way it's supposed to, the way they think it's going to go. The world will correct itself over time, and the animals have got a history of being able to adapt to some really wild climatic change. Humans have not got that background. So that's basically it. The PODMOD is here. It's now in Europe at the request of EC President von der Leyen last March. And we're going through the application to be funded in Europe for European mass manufacturing and installation there, and then for export. I accepted the official request for this because the US government, every university in the US, and every commercial entity I contacted over the 60-plus year history of this project has refused to even think about offering funding or technical aid. And being the Scotsman that I am, I said, to hell with it. It's going to Europe. And they are very serious about it because it's going to be going into Europe, the Middle East, and Africa first. And I figure about the time that it hits the news over here that a US developed, US patented power supply that can be put down and connected at 10 cents an hour instead of kilowatt hour. That's $72 a month for all the electricity each side needs. And if they need more units, that's per unit. This thing can go anywhere. Individual homes, apartments, office spaces per floor, per occupant, commercial sites, and industrial sites that are now needing to clean up their power and lower their electrical power rates. And here's another thing. Each small assembly plant, because we will be burning in the units as they are produced for 30 days, that makes a 69.12 megawatt power plant per 20,000 square foot assembly plant that can be positioned anywhere, like right next to the big dogs coming in, AI development centers and computer data centers, without having to be connected to any power source other than it. And if they need more power, we just put in another assembly plant and they're taken care of. That reduces the draw on the power grids that we have now. We can also retrofit every heat sourced power plant, and that includes atomic, by just doing something that a friend of mine back in the 80s that was at the meeting when I met Steve the first time, I think in 82, was it, Steve? something like, no,
84 maybe.
4, yeah. Nick Butler. Nick Butler was a registered engineer, that electrical engineer that was educated at the University of Washington. And when I met him, he was also the lead for the BPA fund's first wind turbine farms. He was responsible for the research at the universities that was being done, site location, and site design that now are across the Northwest here. I put together a tabletop demonstration of overunity using a unit that I don't think is available anymore, but was called the Paraformer, and it was made by L. Kent Wanless. It had the basic idea right. I carried it further to where it was called load following. In other words, you could change the load on the outside and it would still have reducing the input. The afternoon that I showed that to Nick, he asked to become a silent partner, and he stayed with me all the way through until he suddenly passed away many, many years later. But he named the PODMOD. He also helped me write the patent. That patent went through in a little over 1 year, all 16 claims. And the beauty of it is we didn't have to claim overunity, but we described the hell out of it in the patent. Regenerative feedback is in there. The double tank system is how it works. It's a very basic system, but you can build that thing today and you can have your power supply. And I'll help anybody that wants to do it, because I'm not in this for money anymore. I'm now 80 years young, but I'm caught in a body that got chopped up pretty badly in Vietnam, and I'm physically disabled now. So it's not a money thing. It's a matter of getting this out and getting it built. So it's, I see a comment from a Mr. Gonzalez that is not appreciated, but that's beside the point. It's a matter of, do you want it? It's available. If you like paying what you're doing and having to deal with ever pricing and dealing with climate change and global warming, then you'll stay with what you're doing. If not, you can take a look at this and help us get it done. And that's basically it. There's a lot of information that I'll make available to people that email me at my email address, which is Scotsman7, SCOTSMAN, at Comcast, COMCAST.net. And I will answer any question that's viable. I do not suffer fools or comments that are just really nasty. So if you're in that bag, don't even bother. But if you're interested in information on this, then please contact me. I'll be glad to answer your questions. And I got to have a big shout out to Dr. Tom Vallone, because he was the one that took my information that I'd sent to him and sent it to Steve. And that's the reason that I'm on Steve's show tonight. I owe Tom a big one. And I see that Crypto on Crummets is saying you want to buy one. They're not going to be for sale. They'll be for lease. Because you don't sell something that lasts for 30 years. Economically, it's suicide. So what you do, which we're doing, is we'll lease them at 10 cents an hour. That's $72 a month for a unit that will power your home, because it goes everything from 12, 24, 48, 72, 120, 220, 230, 260, 330, 340, 380, 400 for vehicles, and 480 for three-phase here in the States. And three-phase, it'll be, I think it's 380 voltage for Europe, three-phase. So we've basically got it covered. I've had some extremely good help over the years. I've got 2 great engineering teams going that are friends of mine that are helping us put this together. They're not in it for the money, but one of them has his own PC board manufacturing company, so we don't have to go out and spend a lot of money. They're in it for getting it done. And that's about it. And thank you for your time. And I'll answer any questions.
Well, let me throw something in here. This here is a book that you found that explains what you're doing.
Exactly. Yeah, I forgot about that. Steve has got on the site 5 pages, and this is really important. There's a book called Electricity 1 through 7. It's edited by a gentleman by the name of Harry Mileff, Mileaf. It's copyrighted in 1966. It's got a 55-page chapter on resonance, where today you may get maybe half a paragraph or a couple of sentences, mostly wrong. This has got the chapter and verse of the science of it, why it does what it does. It gives you the mathematics on why it does and what it does, so that you figure out exactly what you need for your particular need. And it covers both parallel resonance and series resonance. Parallel resonance is where the input power is reduced. Series resonance is where it always produces a higher output voltage. So you've got everything to make your own if you want to, and I'll help you do it. But that book is available on Amazon. Now, there are multiple volumes of it. The one that I've got is the one that I can swear to, is the one that's got the green cover and the big yellow numbers 1 through 7, and they've got kind of like a stick house over the numbers. That book is written from the atomic element viewpoint, and this is really important, because it turns out that, getting back to this business of having to go to school and you learn what the teacher wants you to learn while you get through the course, the history of what's called conventional current flow theory I got into because I was taught that in school, and I couldn't figure out what my circuits were doing back there in school. It turns out that conventional theory is based on ancient Greek philosophy. I'm going to give you some facts. The first one is pre-Socrates. They believed that everything in the universe had a force in it. And they named that force energy, Energie. Sound familiar? The next main point, 600 BCE, first guy to write about something like this, Thales of Miletus. And he wrote that he observed dust being attracted to a piece of amber that had been rubbed by a piece of fur. I think everybody's heard that one. Well, he wrote about it. He's the first guy. It's in the history books. He took it one step further, that he decided that because the dust was attracted to the amber, that the amber had to have developed a charge on its surface. And then he deduced, again, this is what's attributed to him writing, was that because when he put that charged piece of amber next to an uncharged entity or a person, a spark would jump from the amber to the entity or the person. So the charge had to be positive. Sound familiar? Next, because the charge moved, the belief became that it was a fluid. Next, because it was a fluid, it had to have a current. Sound familiar? This went all the way through Benjamin Franklin's Kite in the Storm, where it was written down that he said that he saw the hairs on the wet string that he had attached to his kite were raising up. He figured it was building up a charge, which charged a key that he had attached to the wet string. And he deduced this was what was going on because when he put his knuckle next to the key, a spark jumped from the key to his knuckles. He is also attributed to coming up with positive and negative. But the bottom line of it is, conventional theory is ancient Greek belief. There's no testable thing on it. This is where it changed. In 1897, a British physicist by the name of J.J. Thomson discovered the electron while he was experimenting with the new cathode ray tube. Now, he discovered that the electron has a natural negative magnetic value. That's really important to remember, because a nuclear physicist by the name of Tom Bearden, who's unfortunately died a little bit too early, he found by test what actually goes on in an electric circuit. And it's this in short form. When a conductive element, of which there are 4 known, copper, gold, silver, and aluminum, they have something special. They've got one extra odd-numbered electron. It's in the outermost ring. It's called the valence ring, so consequently it's called a valence electron. I don't know how many books have written about free electrons running around in elements. But at least in these 4 conductive elements, that electron, that odd number electron, moves from atom to atom when there's no voltage attached to it. And here's another thing. All the other elements have even numbered electrons. So it's the odd man out. Do the math on it. When a voltage is connected at 2 places on a conductive element, and let's be clear, a voltage is the difference between 2 different level electron volt potentials that are found in a battery at the 2 connecting points, either a straight one or a 9-volt that's got the things on the top. The difference between those 2 potentials is voltage. Now, when that connection is made to a piece of conductive element, gold, silver, copper, aluminum, the circuit is not complete. It is mechanically connected, but it is not electrically connected for the following. At the instant that the magnetic or the connection, the mechanical connection is made, 2 different poles are produced. They're called the more negative, less positive, and the less negative, more positive. This is the reason that they're called that. Ground, quote unquote, designates no polarity. And you can get 12 volts in between 12 volts and 24 volts. 12 volt potential. Okay? 12 volt voltage, excuse me. Well, what happens is when that mechanical connection is made in 2 places, at the more negative, less positive pole, each of those valence electrons adds that voltage level to its negative natural magnetic value, making it more negative. It's not more positive, it's more negative. The voltage travels through the external circuit at the speed of light, influencing all of the valence electrons, making them into voltage-influenced voltage electrons. And that is called the relaxation period. That's what Tom Bearden named it. At the instant that the voltage has traveled all the way through the external circuit, every valence electron that is now voltage influenced moves to the surface of the conductor. Now, it can either be a piece of wire or it can be a trace on a PC board, but they all move in unison. At the end of that action, then they move again uniformly and in unison away from the more negative, less positive pole towards the less negative, more positive pole. That physical movement on the surface of that conductor is called skin effect. Been known for a long time. And it is what causes heat to be developed, light to be produced, and develop magnetic fields in motors and generators. It's got nothing to do with a positive charge moving positive to negative, because classic physics has got a positive charge named as static electricity. It can't do any work. It's work at rest. Now, these are the definitions in the books. I'm not making this up. So what we've got is 120 plus years of being taught incorrectly because certain academics in certain fields of science have refused to clean up their acts. And because of that, we did, as the world, we didn't look. Overunity is impossible. That's the reason, along with the drumbeat from the oil and gas industry, that it goes, burn, burn, burn. We've got global warming on our hands. The PODMOD can straighten this out, but we got to get it in use. That's what I'm trying to do. Everything that I've said is in the books. It can be proven. And everything about current flow is, I won't use the word. And there's no reason that we have to be here. But we've got to find a way to get the guts to move away from what we're doing right now. That's it.
Okay, we have a question here.
Mm-hmm.
Hey, Matt, and he was asking if you did a patent application since the
patent is public. The patent is public domain. A patent is only good for 17 years, and that was 1992. It's public domain information. Anybody can get it. Anybody can use it, and I'm fine with it. I'll help them.
And basically, the plans are right there on the diagram, right?
Yeah. You Google that number, you'll get the patent. All, it's what the way they run it with the half pages, something like 24 pages. But there's 16 claims in there that were all granted. They didn't request any changes or reductions, and they gave me the patent in a little over 1 year. There was no argument. As against Joe Newman ran into.
I got the PDF, which is the whole thing.
Yeah. Let it go. Let it go.
If anyone wants it, just drop me an email and I'll shoot it out to you. If you want email for Scott, if you go to the YouTube description on and it will be right there. I have it as a first line in there now. I went back earlier today and put that up there. So you can drop him an email if you'd like.
Yeah, and that's, again, Steve, that is older information, and I can update it so that it'll work better. Because again, that was 1992 electronics.
Yeah.
It's a whole lot cleaner now.
I remember 92. JW and I went to Seattle, and we saw you there. Yeah.
But right now, to be perfectly honest, you can buy most of the electronics that are on that board from a company by the name of RM Cybernetics in London, England. And there are two versions. I think one's about 110, the other's about 150 pounds. It's got all the electronics on it ready to go.
And let's see. I want to remind everyone, if you haven't, click the thumbs up for us, if you like this presentation, so people will be able to find us, and it really affects the YouTube algorithm there, And we all know how AI is taking over here, even though I hate it. But we still have to deal with it.
Yeah, I see that Mike Doze has got a question about the feedback controller.
Right.
Mike, it is a piece of wire, literally. And where you can put components in it to do whatever you want, but it is literally a loop that goes, they use them with chips now. And you literally take some of the output and feed it back into the input, and how you put components in that wire going back denotes how it works. I'll help you with it if you've got questions.
You know what's amazing is all this information has been in our face, really forever,
Yeah. Well, one of the things Mike's got a good question down here. It's not a choke coil. These are straight inductors. You do not want to use a choke coil. The other thing is you need to look into a product called Litz wire, because pound for pound, you get a lot more amperage out of a piece of Litz wire, multi-strand, than you do on the standard stuff that has been used since Lord knows when for electric power. There's just more copper in it. And when you take into consideration the description that I gave you of the valence electron being the mover, the shaker and the mover, the more copper you got, the more amperage you got. And Litz wire is readily available. For instance, we're using number 36 gauge, 420 strands of it, and it's good for 100 amps, and it doesn't even get warm.
I remember, I think Tesla coil builders use Litz wire a lot.
They did, and there's a big difference between Tesla built three things. The Tesla coil is the resonant step up that shoots out the sparks and everything. He was going to use that for his communication and for literally using the earth as the ground to transmit power, which is what radio frequency is. It's power to any place on the earth. I just took that idea and said, well, instead of having to go one place, why don't you just put it every place that needs it, which is the basic premise on the PODMOD. You can put it where you want it, as much as you want it, as long as you want it. But back to Teslas. The Tesla coil is one. Then he's got his flat coil. And that is really a neat thing, because you don't have to use a tank or a series resonance system to get the voltage increases with a capacitor in series with the coil. The way you wind it is the secret to it, and it's in his patents. It will produce astronomical amounts of voltages, to the tune of, if you've got 100 volts going into it on 1,000 winds, this thing will kick out 225,000 volts. With 1,000 winds straight through, you're not dropping any amperage. And then, of course, the standard series resonant, where you've got his system where you put a capacitor in a series with an inductor, and that kicks up voltage also. I use both. It works. It's in the books. Email address is Scotsman, SCOTSMAN, number 7, the @ Comcast, COMCAST.net, all lowercase. And let's see, that takes care of warning signs. Mike Dodd, good point, copper. Don't quite understand what he means as far as being more 100%. What it does is it gives you more bang for the buck. Like, for instance, house wire coming in is normally 3 or 4 strands of some fairly decent sized copper, because it's out in the environment. Litz wire is rather peculiar, because a number 36 gauge strand of wire is thinner than a human hair. So you've got to treat it carefully. For instance, you've got to make sure that you don't try to make a 90-degree bend with it, because that'll break some of the strands and you'll lose the flow, the movement. Things like this. You need to school yourself on Litz wire. It goes all the way back to the 30s, I think, when it was developed and really used for high power radio transmission in World War II, because they wanted as close to a perfect inductor as they could get. And they found that Litz wire did it a lot better than using single strand. You can make chokes out of it. It works great, but just make sure that you use Litz wire that you can wrap around the choke cord that you're going to use, or else you start breaking it. Phenomenal stuff.
Hey, you got any more questions out there?
Copper penny's gone now. We'll see about the copper pennies. You know, so much has been stated and so much has been pulled back so far. It's a matter of a wait and see.
Well, I think, if anyone's really interested in a lot of this stuff, you might want to go get these do-it-yourself kits and do things like build your own radio receiver, because when you build that radio receiver, you're building a Tesla circuit.
It is.
And here's a question for you. Will you be at the conference?
Yeah, Paul, I won't. I'm either in my chair or when I have to go someplace, I'm in a wheelchair. My back is so bad. And I unfortunately have got something called DISH, which they don't know much about and they don't know what to do with it, but it kind of messes you up. I can't travel anymore. Wish I could, because it would be fun.
Yeah.
But I am available on email or Skype.
And
Mike Doze has got a good question. No, the beautiful part about resonance, Mike, there's no back EMF. I mean, consider it. You're not taking power out of a tank circuit by itself. You have to figure out a way to get it out. That's how radios do it. Because that output signal is actually in ratio to what's coming in. It's more going out than what's coming in. So go to a radio and take a look at how they do it. Any AM or FM radio.
If I remember correctly, we use an intermediate frequency to boost the power on that.
You can, of course. You just add amperage. See, here's the thing. Power is a misnomer. It took me a long time to realize that. What you're talking about, Steve, is you're talking about amperage, which is valence electron movement, and voltage. And you can get yourself hung up if you start using acronyms like power or wattage or energy. I mean, good Lord, energy gets bandied about for everything from soup to nuts anymore. You can't add energy to a circuit. You can't take energy out of a circuit. You can increase the voltage, which will increase the speed of the AC signal, and that will increase the amperage, which is another pet peeve that somebody's got to figure out why they did it. But the SI unit system that the world uses today, they took frequency out of it. You get back to the original equation for what an amp is. That's 1 volt times 6.28 to the 10th to the 18th number of electrons passing a point in a circuit in 1 second. What most people don't realize is that 1 second time is 1 cycle. So if you increase the voltage to 2 volts at the 1 cycle, you've got 2 amps. Or you could stay at the one volt and go to half of a cycle, and you end up with 2 amps, because the 1 second time frame is what is the common denominator that they use. And if you go to 2 cycles per second and you go to 2 volts, it's a multiple. You got 4 amps. You're not moving the amps. You're not moving the valence electrons any faster. What you're doing is the voltage gets increased. You got to think about it, because valence electrons will only move so fast in a piece of copper. It's not a force. It's magnetics. And magnetics have a finite definition to them. And the final nail in the coffin for conventional theory is this: you can't make negatives go together naturally. They repel. So what do you do with an elevated negative electron? And when you got somebody telling you that I got this charge up here, they don't fit. because the voltage is the negative increaser. It eliminates the possibility of the charge doing anything. It's not in the books, but when you take a look at it, that's what's been going on. And what we've done is we've restricted ourselves to exclude resonance, thinking that it always had to be an increase. Parallel resonance, you decrease the input.
So when do you think that you'll have these units out again?
They're under development right now. And again, these are people that have their own businesses to run. So we're looking at being in a demonstration point in less than 6 months.
Oh, well,
at full size. Yeah. I mean, these things they're not intricate. They're a simple thing. It's simply having the time for his people in both cases to spend time to put them together, because the boards have already been built.
Well, if they have one ready by the conference, maybe you can send a rep with a demonstration model. They can do a quick demonstration.
That'll happen as soon as we get it done, because we're not going to worry about patenting the damn thing.
Yeah.
I'm not worried about getting cut off or anything like this. I want the thing out so we can get it into use.
Okay, now here's a question for you.
Why didn't they put them out back in 92? Number one, didn't have the knowledge to today, and we didn't have the electronics. The components were just not available. Back in 92, the biggest MOSFET that you could get was a big hockey puck. That was a 5-watt hockey puck. Look for a driver, build yourself one with a whole bunch of components, and then nobody had any schematics. They were just beginning to get into it. I mean, I caught it just at the rise when electronics started to take off, and I've been working through God knows how many variations, keeping it as simple as I possible.
Yeah, back in those days, I worked for Unisys.
You know the drill.
Yeah, and I was logic circuits is my specialty, and we tested parts. All different parts. Anything that goes into a defense.
Yeah, and we're going to test them, till they break, because electronics has got a basic premise that if you can make it work for 30 days, it'll work for 30 years. Because this is not a unit that you turn on and off. You can stop using it, but it's still there because it's set up as an on-demand system up to its maximum. It will not produce more than it's designed to do. So we make sure that we've got standard house wiring. For instance, here in the States, you got 2-phase, 120 volt, 60 hertz, 100 amp per phase. That'll be one unit. All the way up to 480 volt, 480 amp. Same unit, just with more output.
Here's a question for you.
Okay.
Can you talk a little bit on back EMF?
Back EMF is standard. What happens is, if you have a load in an AC system that's got a transformer in it, or if it's a straight through connection, if the load changes, it's 99 times out of 100, it's an inductive reactance change, a motor. That reflects back to the front end because it drops voltage. And the power supply from the wall has got to supply more voltage to get the amperage back up in atomic sense. If you're talking conventional sense, then they say power. But it basically is, when it changes here, it reflects back. The way that I've got the PODMOD set up is that there's no magnetic connection between the input and the output. And this might throw electrical engineers out, but it nullifies Lenz's law, and yet it works. That is proprietary. But I will show people how they can do it under standard conditions. It's called load following. And you can make these things, you can make that 1992 unit load following, so that if you do get the change in the inductor, it will not reflect back. You can do it.
Okay. And he says, I have good results with high impedance.
You're right. He's right. Yeah. Depends upon the use that you're using for. I mean, it's electronics. They do one of two things. They either work or they don't.
Okay, here you go. Can you discuss the
Okay,
significance?
constant current controller. Actually, to be perfectly honest, the way that it works is that we've got a master slave system that's not magnetically connected. So anything can happen in the output as far as load changes, which we've got compensating built in, but there's no direct connection back. So you've got a constant current master driving a slave output tank, which is basically a variation of the two tank system in the patent.
Okay. Any more questions, or? Well, we've taken up an hour.
You got some good questions, good people.
Well, these are great people. You know,
Yeah.
all Tesla Tech people are great people. And I like to remind everyone,
Well, he certainly was misunderstood.
if you're not already, go to the YouTube channel and join. And when you go to the channel or the Steve's place, look underneath Scott, and in the description there will be his email address for those who forgot. And here's another question here asking about Lenz's law.
Yeah, Savage 1R is not a bad person. You're totally entitled to your opinions. As far as Lenz's law, it's called mutual inductance between two coils on a transformer core. And those are always in the same parallel axis. I'll just say that the axis in the PODMOD of the two tanks are not, the two tank circuits are not parallel. It's called orthogonal.
The magnetic separation by air core use.
No air core, no gapping. And we're using a material called MPP, which is moly-powdered permalloy. It's manufactured by Magnetics Inc., and it's good up to a couple of megahertz without having any reluctance in it, which is the nice part about it. You don't get any of that overlap of the dipoles at the zero crossover point. When it crosses zero, magnetic polarity per half cycle switches.
Okay.
Ferrite won't do that.
Well, I want to remind everyone before we leave here, we do have a conference coming up in August 6th or 10th. If you sign up in the next 24 hours, I give you an extra 5% off. But with that, I'm going to go ahead and close out. Thank you all for coming, and remind you all to see Steve's place next week. I think we're going to have an ozone generator here. But anyway, we'll see for sure this week. And you all have a great day, and we'll see you next week. Thank you.